Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night, and apologies for that little slight delay. What we've got tonight is a continuation of our resonance series, and we have, let me just go to the close-up camera, we have a segment on crystals, and yes, that is a rather large crystal that we'll be going into in a short time. So focus on resonance. The recollection from last week and the week before. What's resonance? Resonance is obviously the phenomena where you get increased amplitude of a particular frequency due to a force that's being applied to a particular system. And that's probably the easiest way, and they refer to it as being the natural frequency of the system that the energy is acting on. And I gave a bit of an idea of an antenna that I've got where if the wind, which is the energy, is acting on this antenna, you get an audio frequency out of this antenna. Just when the wind's just right and from the right direction. So it's called the resonant frequency of that antenna or that system. So what we're going to do today is a little bit more on the specifically the RF resonance part and an in-depth look at crystals. So crystals, and you can see one on the screen now. This is one I collected a fair while ago. You can see it's a hexagonal form, and it's got a beautiful end on it. It's obviously at the time was broken off of a larger formation, but absolutely amazing, the crystal form, and I'll go into what actually makes up that crystal form and how it is really advantageous to us when we talk about a crystal as a resonator. Crystals, and especially quartz crystals, in this particular case quartz crystal. There are many other crystals from different substances, but in this case quartz. Quartz is one of the most prevalent minerals in the world. It is silicon dioxide, so it's a silicon atom and 2 oxygen atoms, and that's actually key to why you are seeing the hexagonal form that it's in. It is extensively used in the RF industry and any industry where there is a frequency reference required. You will find a quartz crystal somewhere in that system, usually setting a frequency or a range of frequencies, and it is known to be very stable at the resonant frequency that it is cut for. Now, a little bit of history, just a little bit of history here. Peizoelectricity, which is where you get a crystal in between two metal plates, and if you move that crystal and flex that crystal, what you can actually find is there is a voltage induced on the actual plates, and that phenomenon was discovered back in the 1880s. So it's been known for quite a while that if you put this crystal and flex this crystal between these plates, then you actually generate some electricity. And in fact, there are some interesting uses. There's been a trial of road surfaces in, I think, the Netherlands, where it is using that piezoelectric effect. So as vehicles drive over this road surface, it actually generates electricity. So it's actually using that effect. We then jump a little bit further on to World War I, when they started using RF, so radios, to do communications, and they needed to get some stable frequency sources, and magically they realized that quartz crystals, quite primitive quartz crystals, can actually give you that stability. So what we started to see, World War II, quartz resonators appeared. 1920s, 1930s, you've got quartz oscillators, and also they realized that they could then use it in a clock. The accuracies that are quoted here is up to 1 second in 30 years. So that was pretty accurate for the time. So they realised they could use it to drive clocks and then timing. And there's a couple of wonderful pictures on the net around the crystal oscillators that they actually used in the National Institute for Standards, NIST, in the US, and there are these large glass envelopes with these huge crystals in them, all next to each other, being summed and getting stable frequencies out of them. So absolutely fascinating. Now, how does a crystal actually do this? And when I started researching this particular subject, I suddenly remembered. For those who don't know, I did geology and geochemistry at university. That's my degree. Although I've never actually used geology or geochemistry in anger. But what we did was learn crystallography as part of our course, and some of the, and I suddenly realised that I actually had some of the still had some of the textbooks, and if there are geology students out there, they would probably recognise this one, Mineralogy for Students by Batty, and also there was another one which was used, I think, in third year, which was the rock forming minerals by Deerhausen and Zussman, which is, if you're into igneous and metamorphic petrology, this is probably the book that you've got. But there are some excellent diagrams about the crystalline structure, and so what I will do is we'll go to this is the quartz crystalline structure. Now, what it actually shows here is I talked about it, quartz crystals being made of silicon dioxide. So it's a silicon atom and 2 oxygen atoms that are connected together. And what you can see is the way that they are put together at an atomic level is there are all of these little triangles, which is the silicon and the 2 oxygens, which are then connected to another 2 oxygens, and they're put together, and this is a slice through the crystal at an atomic level. And you'll notice these are the silicons, and you'll notice that because of the way that they actually connect atomically, and you'll see these are at a slight angle to this layer. These are turned slightly at this angle, and then there is another line of straight aligned atomics, molecules. I should use the right chemistry. So silicon dioxide molecules along here, and this repeats over and over again. And what you end up with is if you then come up to, so this is at the microscopic level, if you come up to the macroscopic level, which is all of these put together, millions and millions and millions of them, you end up with this hexagon shape and the termination at the end, but you end up with this hexagon shape, which is one of the most common forms of quartz. Now, it's not the only form of quartz, but it's one of the most common forms of quartz. So at an atomic level, there is this absolute symmetrical pattern of atoms, and in this particular, these rings that you can see, these rings vary slightly, and they actually spiral up through the crystalline structure. So that's one way of showing the structure. In another way, this is Mineralogy by Batty. Hello, Warren.
Justin, good evening.
Have we got Alan or Rex? Just a matter of interest.
Alan is here. Yes.
Okay, cool. Mm-hmm. Cool. So, by all means, take a seat. We're on the close-up camera, so you don't have to worry. So, if we look at now, this is the same diagram, but in a 3-dimensional form. So you can see these are the silicon dioxide atoms in a what look like a cone shape. Now these are double-ended, so you can't actually see the other side of these, but they form those regular layers of molecules, and then that spiral or that circle of molecules in the middle is what this form is here. You can see it probably slightly better here. You can see there is this layer here and here, and then there is these spirals that are interlinked. And what actually happens is, whoops, that just went west. What actually happens is, as these layers, these are the aligned layers, and then there is the spiral in the middle that comes up, and you can see that there are slightly different types of quartz. They talk about high and low quartz, which is all to do with the temperature and the pressure that the quartz was actually formed in. But you can see here, this is the high quartz. The high quartz has the spiral, and the low quartz has a less of a spiral, so it looks more symmetrical than the high quartz, which actually has, because of this slight offset, is what causes the spiral of the molecules. And just so I'm not telling porkies here, this is this is the chart for quartz, which I think from memory we had to learn because it was in our assessments. But you can see this is the pressure under here, and we're talking about pressure at depths of 5, 10, 15 kilometres below the crust and into the 60, 80, 100 kilometres into below the surface here. So we're talking about pressures of up into the 100, 200, 300 meganewtons per metre square. So this is huge pressures, and also temperatures, 500 degrees C, 1000 degrees C, 1500 degrees C. And at those low temperatures and pressures, you start to get this low quartz forming, and then at much higher temperatures, and as we go up in pressure, you get this high quartz, and then at these really high temperatures, you get tridymite, cristobalite, and into the liquid form. So, and at really high pressure, you get cresite. So different forms of quartz. You might look at quartz on the beach on the sand and think, oh, that's only quartz. Well, there's quite a bit that goes into the crystalline structure of quartz. Now, okay, how do we get from this into this? Well, what I've got here, I've got a few different forms of this. Just bear with me, and I'll grab one that I can take the top off. That I unsoldered the top so that we could have a look inside. So this is what it looks like, and you can see there is a disc of quartz. That's the white disc of quartz. In fact, let's go there, and we'll zoom in here. That's better. You can see the white disc of quartz. Where's my pen gone? There it is. There's the white disc of quartz, and you can see there's a little bit been shaved off the top of this to adjust it. And then there is a plate, a gold plate on one side, and then if I turn it over, there is exactly the same gold plate on the other side that's actually plated onto the quartz. And then there's these little spring arms in here, and they're epoxied on so that they connect, number one, to the plate, and they hold this plate in the middle, away from everything. So there's a bit of physical separation in case there is some vibration. And then there's a metal can that goes on the top of that. So how do we get from this to this? Well, through some very tricky diamond saw cutting. Now, I showed you this the other week. This is a quartz crystal, and some of the cuts on a quartz crystal, and you can see this is a very similar form to what I showed. It's the hexagonal form, and you can see if we cut a bar that is along that form, it's what they call the X cut. And then if we cut across the form at 35 degrees from there, it's a AT cut. And then if we cut at one of the other faces in a slightly different angle, we get the Y cut. Now, the XY and the AT cut are the most common forms of crystal that is cut out of something like this. And you need to know the form and where it is and where these faces are, and then measure from these faces. So you need to quite accurately, and there are diamond saws set up so that you can clamp something like this and then do the cuts on these. And then what you then need to do is thin it right down. So what they do is they then grind it down to a particular thickness. And then they put it in a little jig and they start grinding, and then they grind a little bit more and they get to where they want to be, and then they start cutting. You can see the ends has been cut off of that, and you end up with Just bear with me. Sorry, I'm jumping around here. I've got quite a few crystals that I brought along out of my junk box just to show you all the different forms. Now, this is an X-Defense crystal, Brooks crystal, 5 megahertz, so 5,000 kilohertz, defense reference number. If we open it up, this is all Bakelite canvas. So I'd say this is probably early World War II. And you'll notice if I open it up, there is one plate here, quite a heavy plate, and then there's another plate on the other side which is connected to these two pins, and then inside here there is a crystal plate. Very, very thin, but it's the right cut and the right thinness, and you can see there's the other side of the plate there, and that's cut so that it will resonate between those two plates. Once you screw this on and it clamps the two plates together, it will resonate at 5 megahertz. So, and a trick that amateurs used to do with crystals, because crystals were quite expensive, because there was a lot of work involved in getting to the frequency that you want these days. And so what amateurs would do, and you can see I've got a couple of them here, what amateurs would do, there were crystal holders like these that enabled you to unscrew these, and there are two plates in there very similar to this one, and you could use paste like toothpaste or jeweler's rouge or all sorts of things, and what they could do was then tune that particular crystal to the frequency that you actually wanted. So, alright, I'm just grabbing the mouse, which fell down. So, there are all sorts of forms, and what I'll do, I'll just show you a whole range of different crystal forms. There is this form, there is even bigger, and that's 9 kilohertz. That's a different form as well. There's a Collins crystal. There's an AWA crystal. There is a standard radio crystal. There's a 8.4 megahertz crystal. Now we go into the modern versions. So this is a slightly more modern. There's a crystal oscillator. There's a crystal actually in that, and a little IC that does the amplification of it. There's a different, that's probably a bit more modern, that particular crystal. There's a surface mount crystal. I'll leave the resonator until later. And then there is an even smaller 32768 kilohertz crystal used in clocks and watches. So, and that's actually a tuning fork, what they call a tuning fork crystal. And a tuning fork crystal, when you get down to the really low frequencies, one of the ways that you can make it a bit more efficient is to actually cut the crystal as if it's a tuning fork. And it actually acts as a tuning fork, as if the two poles of the tuning fork actually resonate at the frequency that you actually want it once you apply the external energy. So there's an array, and this is certainly not an exhaustive array of crystals. They came in all sorts of forms, but they are all the same. They all contain two plates. There's a crystal in each one of them that is cut for the particular frequency that they're cut for, and they are all used for frequency stability. So now, how do we how do we tell if we get a crystal that hasn't got a marking on it? A bit like that one, it's got 15 megs written on it. So obviously someone's measured it. But how do we how do we measure what the frequency is of the crystal? Well, the wonderful grid dip oscillator that I had last week, you can use a grid dip oscillator to give you a bit of a rough idea about where the frequency is. And then next week, what I'm actually going to do, once I've made up a rig for it, is show you on a Nano VNA how you measure the frequency of a crystal, and you can do it really accurately. So I've got our grid dip oscillator, and this particular grid dip oscillator enables you to plug in a crystal. Mm-hmm. This is not always, not all grid dip oscillators actually have this function, but instead of it being a coil, and you can, if you remember last week, there are a bunch of coils that we can use which are all tuned. This is the C coil, which goes from 3 megs to 7.4 megs. Instead of plugging in a coil, you can plug in a crystal, and then basically sweep the crystal. So if we plug that in, we'll start it up, get you can see the meter, we'll centre the meter, and we'll, what are we actually on here? Actually, no, we have to, of course. We have to put in a coil. Of course we do. So, now, what was that particular... Oh, it was 26. I thought it was pretty high. That's a 26 meg crystal. So you can go through your coils and see whether you can get a dip out of it. I'll jump to the one that I'm actually know that it's about right on, and I'll just hold that crystal in. Now, what we've plugged in is number E, so we're on this scale here, between 20, 25, we're coming down, oh, okay, 20, 25, going up, oh, okay, we get a bit of a dip around about 25, 26. I tell you what, it's really, really sharp. There, you can see. I've just got to make sure the crystal's actually in its socket. Just bear with me. I've got I haven't got big enough wire for the socket. That's the problem I've got. Yeah, you can see it's bouncing around there. I'll just hold it still. Oh, there we go. There. And it's right on about 26 and a half, which, if I read off what was on here, it's 26.4. So there you go. So that's one way you can use a grid dip oscillator around to find out what the crystal frequency is. And if it's unknown as to what the frequency is, what you can then do is work your way through each of these until you find where that dip is. The only problem with that is, potentially, it's an overtone. It's not the fundamental. So you really have to take probably a bit of a note of what sort of dip you get. And the deepest dip is probably the fundamental. But, yeah, you can't really guarantee that. But next week I'll show you how to use a Nano VNA. I have to make up a little jig to put the crystal in to use on the Nano VNA, but they're very simple to make up, but I didn't have time this week. So anyway, that's how you use a grid dip oscillator. Now, I'm going to have to get you to just move, Warren. Because your wonderful head, on the back of your head.
I'll just put this box over here, maybe.
Oh, cool.
And then
Cool.
we can put the chair over here.
So So that's a little bit about crystals, and honestly, you will find crystals almost everywhere. They can be in really small forms, they can be in slightly larger forms, they can be in oscillator packs. The thing about oscillator packs, really nice using oscillator packs with digital electronics, because what comes out of here is a square wave, an amplified square wave at exactly the right amplitude you want and the frequency you want. So for CPU clocks and communications clocks, you'll probably find this sort of package. It is the size of a dual inline 16 pin or 14 pin package. So it just plugs into an IC socket, and you just give it 5 volts and you get magically get the frequency at a square wave out the other side. So these are really nice to use. So yeah. Now the other frequency determining thing, and I'm not going to go into these in a big way, but crystals are very expensive for what they are quite expensive, because there is a lot to manufacture them. One of the things that you hang on, I'll put it here. Probably easier. One of the things that tends to replace crystals these days are resonators, and this is a 3.58 megahertz resonator. Now 3.58, surprise surprise, was the color burst frequency. So there were lots of these around, as well as crystals that were used in color televisions for a long time, and so there's quite a few of these around. The thing about the 3.58 megahertz crystal is it's in the amateur band. So it's really handy. So if you've got 3.58 color burst crystals, don't throw them away, because literally you can build a CW transmitter really easily with one of these and a hex gate, CMOS hex gate, and you've got yourself an oscillator, an RF oscillator at the amateur bands.
So what's inside a little resonator like that?
Very similar to what's in here, actually. Mm-hmm. Not a crystal. It actually is a form, a different form. But when you apply, it's like a mechanical resonator. Mm-hmm. I was going to go into that next week. So because I haven't done a huge amount of research on the resonators, but the key thing of what a crystal is a really high Q device. So it gives you, it actually gives you very narrow bandwidth, because it's resonating at only the frequency or the overtone that it's designed for. Whereas a resonator is a much lower Q device, actually greater bandwidth. It actually gives you a much greater spread, if you like, and you can get. Yeah, you can get crystals to do things, but you can also get resonators to do a whole lot more from a filter perspective. And just to mention that, you can use, because they're really high Q, you can use them for filters, really high quality filters. And a lot of receivers that are considered to be really good receivers have crystal filters in them. And the crystal filters are usually made up of a whole lot of crystals at particular frequencies with associated capacitors in the form that makes up a filter for a particular frequency that you're trying to filter in or filter out. And in fact, I've included a video in here from Peter Parker, VK3YE, who goes into, he has a whole lot of he's a bag of surplus crystals, and says what can you do with them, and he actually goes through and makes a crystal filter with them. And there's quite a few videos I noticed on the YouTube around crystal filters. So if you've got a lot of crystals and they're the right frequency, you can make some really nice crystal filters with them as well. So they're not only frequency setting devices, they're also high Q filtering devices as well. So there you go. So anyway, that's I hope that's given you something that you didn't know before about crystals.
Yeah, I look forward to next week too, to see, because with the VNA, presumably you'll be doing the sweeping.
Well and truly. And in fact, the VNA, using the NanoVNA, And one of the things that you can do with the Nano VNA is narrow down, because Nano VNAs, one of the issues with Nano VNAs is they only have a fixed number of sample points. And so when you do a sweep over a high, sort of a large frequency range, it's only taking sample points at every, so you miss a lot of stuff. But what you can do with once you determine where that resonant frequency of the crystal is, and you can then measure that with the frequency, what you can do is then reduce the bandwidth that you're sampling, and then get really, really accurate and more accurate based on the frequency that it's actually resonating at. So you zoom into that. So your 101 points on your Nano VNA is suddenly going across, 10 kilohertz, not megahertz. So you can actually use the limitations on the Nano VNA. You can get over those. That's probably the way of putting that. So, but anyway, I'll make up that little jig, and it's actually a really useful jig for the Nano VNA anyway. So it's worth making it up, and I'll go through how you make it up. So yeah, excellent. That's crystals. So next week, I'll do a little bit on the resonators, and also some of the oscillator circuits, and the way that the crystals and the resonators are used in those oscillator circuits. That's probably the next instalment. Now, Roger's here. We want to get Alan in.
Yep.
We'll just do a bit of a setup. Warren brought in a picture, and I've actually got the picture here.
Oh, you've got it? Good.
I've got it. I'll just get the picture, just talk among yourselves. Prince Charles AAD radio, there you go. Now, I've just given it away, haven't I? Oh my goodness. Oh my goodness. So,
I'll just say it's his mind. It's
Rex.
No, Rex isn't here.
Rex is the one who knows. Yeah. Name him off by heart.
Now, so, we can get two of you in here.
Or can you bring that chair?
Bring that other chair.
No, come on. Hold me first.
Now, we got a...
What are we talking
Oh, we've got Kim as well. Good.
We've got a cast of thousands in the studio. Can I get...
Okay, yes,
5.
Okay.
That'll do.
That'll do. Is that okay?
We'll go around here, and I can show.
Hands up, who's been to Antarctica?
How many times?
Hands up those who haven't been.
How many times?
I think I'm in that. What you can see now. Where am I? I'm at number 2, aren't I? Yeah. So here's where we have in the studio. It's Warren. Hello, Warren.
Good evening.
We've got Alan. I can't raise you up there, Alan. And we've got Kim, and we've got Roger, and we've got Alan again. Yeah. You get that. So I'll try and switch between the two of you. If I put that on there, that's good. Now, so let me just go to the PC. Oh, come on. Now, which one am I on there?
So presumably Rex hasn't turned up out there?
No.
No,
not tonight.
No, it's too wet for anything. It's hibernating. It would have been pretty wet up on the hill.
It was.
That's certainly wet at Mount Nelson.
Now. Yeah, he went through that photo a few weeks ago. This person.
Yeah, I should have written down notes at the time.
On the photograph.
Where now, Kim?
Yeah.
Can I get you down on the floor? There is a D-type, a display port connector somewhere there.
There.
Beautiful.
Where do you want it?
Up here. I'm thinking, why haven't I got something coming from the PC?
It's because your cable's jammed in your book.
Because
That's what it is.
So
You got enough slate now?
Yeah, that's good. That's excellent.
I really like your cabling. It's very tidy. Out of view, out of mind, off the screen.
Correct.
We should put the camera down there.
Correct. Now, why haven't I got something on here?
That is for you to know.
Us to find out. Yeah. Okay. What's going on there?
Gonna have to get a fisheye lens here.
We can do NanoVNA photos.
We are.
Yeah, thousands of them.
Where did that? Oh, there it is. Oh, yeah. Okay. I don't think that should have done that.
If you've got more cables that aren't where they should be.
Correct.
Well, something happened.
Something happened. Standard, underscale, and power. Okay.
I wonder if the cameras in my car does this occasionally. Except this afternoon it was the other one of the others. They're everywhere.
What, cameras?
Cameras, yeah.
In your car?
Yeah, they're everywhere.
What, every direction?
Yeah.
Okay, so it's probably wet weather then, eh?
No, don't know.
Well, didn't do it yesterday, it's doing it today.
One of them has been doing it on and off.
Ah, I'm sorry about this. Have you got it on your phone? Has somebody got it on there?
Oh, the picture?
Yeah.
Yeah, okay.
I can't for some reason get it up on the screen. It's refusing to bring it up on the screen. But anyway.
Bottoms up.
Gin in there?
No, just the leftovers of my coffee. I'll go and watch it out. I'll be back.
Here we go.
Invite me for the next instalment.
Will it be this last one?
Ah, there we go.
Oh,
I love it.
Okay.
I love it. Okay. So.
Might have to turn the brightness up on my phone.
No, that's all right. That's okay. Let's go to the close-up camera.
Oh, that'll do.
Oh, yeah, that was a bit of a nasty transition there, but there we go.
No, it was better before. Blow it up.
Blow it up.
Yeah.
Is that a statement about royalty, or is it?
No. The division.
Printed version of that? No, I don't.
Now, okay, what we've got is take us through what this event is to start with.
Yeah, well, okay. What we see in this image is 1981, when the Antarctic Division had moved from Melbourne to Hobart, or to Tasmania, and the official opening of the headquarters, of the new headquarters in Tasmania in Kingston, was carried out, would you say?
Cool.
By the Honourable Prince Charles himself.
Okay.
So
So he actually opened the Kingston.
yeah.
Yeah.
There's a plaque on the wall.
Oh, okay.
Yeah.
Okay.
Is it?
Yeah.
Oh,
On the stairs that go upstairs.
I wasn't here then.
Well, the plaque's still there.
Yeah.
It's been there since 1981, maybe.
It's been there for 40 years.
Yeah, that's okay.
So-
I was out of the country then.
So somehow, I knew about that, and a couple of weeks ago I was browsing one of my favorite op shops, a plug for the Salvation Army thrift shop, and there was this hard copy book there titled Royals or Royal Visits to Australia. And I kind of just opened it up in the middle, and then the first thing that appeared was this picture.
Oh, okay.
And it talks about the AID. And that was the only picture dedicated to that particular event.
Okay.
But I knew straight away what the story was. But what intrigued me was the fact that Prince Charles is using a ham radio. And I thought, with the regulations, hams are, hams have ham radios, and governments have government radios or
It's a government frequency too, no doubt. Except there's a
industrial
backstory, isn't there,
radios.
I can neither confirm nor deny.
And like for, I remember some years ago traveling the outback was a ham friend of mine, who on the official
was him.
what was that radio network called?
Which one?
The one that you're not supposed to use ham radios on.
I don't know. I didn't.
Or FTS?
No, VKS737.
No, there's the one that the that non-ham people can use.
There's
Was
lots of
100
those.
watts to radio.
The Outback radio.
The Outback radio.
The Traveller's Net.
No,
the one between the
it's-
stations.
It's RFDS.
RFDS
okay.
station hookup one, where one
Yeah.
station can talk to another station. Like
Right.
still of the air type
Yeah.
stuff. Those frequencies.
Yeah. So, and I think on this trip we gave a daily update as to where our location was in the outback.
Yeah,
Okay.
that was on the Traveller's Net on 14116.
116. Yeah.
Well, you were in the Prado.
Yeah.
Well, you wouldn't have to update the position by very far each day, then, would you?
No, and that's not because we were towing a Jeep or a Land Rover.
Yeah.
Okay, returning to the photo.
So, anyways, returning to the photo, my recollection was that, just like, sort of modifying a ham handheld to work on CB frequencies is actually not really the, if you're using citizen band, you're meant to use a citizen band radio. Well, anyways, long story short, it becomes apparent in this picture here that that the radio equipment there is Collins, and my first exposure to ham radio was a club station that had a beautiful Collins lineup. So I do recognize Collins equipment when I see it.
Do you know which ones they are?
Well,
He knows because he sent a message to somebody.
That's
Ah.
the KWM2.
I'm hoping Alan can enlighten us and Roger and Kim
Sorry, Alan, it's just...
what those Collin radios are that we see in the picture. Just referring back to the ham club that I discovered ham radio with, I have managed to find a historic photo on the internet which shows exactly the lineup as it was back in the late 60s, early 70s.
There's a lot of
when
Collins gear there.
There is a huge amount.
yes, so
Hang on, sorry.
this wasn't just
going
a
on.
ham club. It was actually a facility, almost like a adult
Focus.
education institute,
Okay.
and
With teletype.
they had received a substantial grant for the education of youth, if you like.
Okay. Okay.
And that's how they managed to establish quite a handsome ham radio station. And so it that's the only picture that I have of it from them, but quite happy that
Okay.
that's
Just
appeared.
flick back to the picture for a sec, please.
No.
Thanks, Justin. Okay, from the right, with the lid held open, it's a 30L1 amplifier,
Oh, okay.
which has got 4 811s in the finals.
Okay.
Needs 100 watts to drive it. Next to it looks like a KWM2A.
Okay.
The one directly under your pointer, which is your biro, that's a 302C1 maybe. That's a watt meter,
Okay.
an SWR meter.
Yeah.
The next one, it's getting a bit far away. I think it's another M2A.
Okay.
And then that I don't know.
That's a speaker, I think.
It's a speaker. Oh, it's a 3. This is getting hard. 312B3.
Okay.
And
That's got one dial.
I reckon
Yeah,
that's another
that-
KWM.
yeah,
I'm wondering-
or a receiver, I reckon.
Yeah.
And that the one above it might be a KWM1.
Okay.
It's a bit hard to see. It's a bit grey.
That
and
looks
then
like a rotator.
That's a rotator, and then I reckon the power supply for the M1's on the left, and on the left-hand side, right over, with the dial on the bottom.
That
I'm
one?
not sure what it is.
No,
Could
okay.
be a B4 maybe. The
So it's a
station control.
Collins lineup.
It's a very big Collins lineup.
They also had a 4x2-way interface, didn't
Mm.
I think that might be in the
Yeah.
picture.
Okay.
they? Yeah.
Yeah.
Very good. Very good indeed.
Well, so where's our photo again of? We have to.
Now
It's gone to sleep, has
Sorry,
it?
It's gone to sleep.
Let's
see.
get some. It went on amateur views.
So,
People using
there
their own
we go.
visions.
Yes.
Cool.
Yeah.
I know what they were.
So let's go back to our photo. And zoom.
1925.
Zoom in here.
There's a 4040 and there's a 5400.
So who
Which
who
are
are,
aviation ones.
who are we looking at? Like this is obviously Prince Charles.
Oh,
Yeah.
is it?
Yeah.
Who's this?
Terry Weatherson. He
That's right.
was the STO radio back in those days. He was my boss.
Okay.
He employed me.
And he interviewed me.
1980.
It's interesting he's here
There you
because
go.
he didn't want to come.
I don't know who that one is.
Isn't that the
That's the
minister?
That's
Minister.
probably a minister.
Sinclair?
That's
In
a
those days,
photographer.
Yes,
Yeah.
What
photographer.
about this guy?
Don't know. I can't see that
What
far.
about this guy?
He looks like a poly.
Yeah.
Yeah, he's probably the minder for
Yeah,
him.
yeah. Unknown. And that's Clary McHugh, who was the director of the division at the time.
Okay. Well, there you go. And the very 1980s, 1970s, 1980s digital clock.
Yeah.
Which survived for many, many years.
Okay.
And
They were
that-
still around when I started
As
at the
far
division.
as the Collins gear goes,
Yeah.
if you want to get with your biro,
Yeah.
I've got, that's the interface to various things. I think we could patch into the telephone line.
Yeah.
I think
Yeah.
that's what
Okay.
that is.
312B4.
Yeah, okay. That's a Collins KWM2A.
That's scary, Kim.
Yeah, I thought,
Yes, it is.
what's that, Alan?
I'm not sure, but there's a 30S1 linear in there
Underneath
somewhere.
it.
Underneath
Yeah.
it.
Yeah, okay.
So I don't know what that one on top is.
Yeah, it could have been a receiver.
Uh,
I might have that station because I've got a 30S1 and I've got a K2M2A, and there weren't very many of those around on the stations because some of the
there was
stations.
one at each station.
Was it? Well, where did the 32S3 transmitter go?
Don't know.
There was one of those down there too.
Oh,
And they're all bought. In Melbourne, there's another photo of, I forget who it is, operating the station in Melbourne before they
Yeah.
shifted down.
Yeah.
But it was all winged emblem, whereas this stuff was all bought in about 1972, 73, because it was the round emblem. The original
Okay.
columns, well, no, not the original, but one of the
Now
later
it's getting
columns.
scary.
Yeah, Collins emblems was round with wings on it, the aviation connection,
Mm.
and then they went to the round one, which the Yanks call meatballs.
Okay.
And that was
Mm.
in 72, 73.
Interesting.
That
Yeah.
equipment was the first equipment I'd seen for the division. That was in Melbourne. It was in 368 St Kilda Road.
Mm.
And they had a tri-band beam on the roof with a rotator, which wasn't necessarily used on amateur bands.
Right.
It was used on, there was one that was very close, 14415, which was, yeah, obviously
And
close.
this is when they had the big rhombics down south. Is that
Yeah.
Yeah.
this era?
Yeah. Yep. All stations had a rhombic. Casey and Mawson had log periodics as well on
Okay.
a 150-foot tower, vertical log periodics that went from probably about 4 megs to 30 megs.
And they were made by AWA.
Yeah,
Okay.
the rhombics worked better.
There you go.
And also conical
I
monocle.
love it.
And conical
Oh,
monopole.
a comical
Yeah.
monopole, which worked as a very good dummy load.
There's still,
Comical
Yes.
or conical?
well, performance was comical. There's still V's at Mawson, and there's still V's at Longwise, V Longwise, at Casey. There's 6 still at Casey, although a couple of them fallen down as a job this summer.
The rhombics at each station were much the same in that they were 400 foot per leg, so that's about 760 feet from one end to the other, I think, between the towers.
Yeah, okay.
Yeah. So on 72 foot towers generally, although at Mawson they had a couple of shorter ones to make up for the strange contours we had down there. It was rocky.
Okay. Well,
Yeah.
And
Yeah. So
just
also.
make the point, that wasn't on the amateur band. Really.
no, they
No.
were AAD frequencies, allocated frequencies. Yeah.
Another one of our Antarctic Reast members is Herman.
Oh yes,
Herman.
yes.
Um,
VK7HW.
HW.
Yes, that's right.
Who entered in-
Recollects that the call was mentioned. The call was mentioned in the Casey April '81 newsletter. Looking at the Collins equipment being used instead of the Radphone call, it must have been a call on one of the AAD frequencies, which is what we said. At Casey end, we probably used one of our main transmitters. We did have Collins gear as shown for our emergency comms. Now, hang on.
Yes, that's a point. Those KWMs at the stations were all used as the backup for the main comms, and they were sited away from the radio office or the transmitter huts.
Okay.
So that was the emergency.
Yeah, and the guy resting his hand on the equipment, which is this guy you've identified, is Terry Weatherson, Silent Key, who was the senior radio tech guy in charge of us radio techs.
Yes.
He interviewed me for the position.
Yeah. Herman wintered in 1981 at Casey when I was at Davis.
Yep.
So.
And VK0HW, he was then?
I was VK0AJ.
Okay. And we received a call on the Radphone to get the OIC, so the officer in charge, to the comm centre as Prince Charles was going to speak with him. It was an official opening of the Kingston HQ, and I left the Antarctic on the Thaladan from Melbourne, where the HQ was at the time, and came home in early '82 to Hobart, where the new HQ was.
That's right. Yeah.
So there you go.
I left on the Nilladan.
And that's from
Melbourne.
That's from Herman VK7HW. So thank you. Thank you.
That's
Herman.
good.
So good stuff.
Yeah.
Any other recollections about this particular photo? Because this is flooded back a whole lot of memories.
Whereabouts was it, that room?
I don't know.
That was probably the original comm centre.
Yeah.
Next to the comm centre, down below.
Okay.
Before they extended the building.
Ah, right, okay.
It moved around several times.
Yeah.
But the,
I've lost track of it over
but
the
the comm
years.
centres tended to, for a while, tended to stay downstairs on the left-hand side.
Yeah, okay.
Towards
the room
towards the
next to
pond.
it was where that equipment was. Later, it was then used there's a rack of all the interfaces
yeah.
and that one.
Okay.
So they were running 10 kilowatts
Where?
on the stations.
Oh, on the stations.
On the stations.
Yeah.
So yeah, 10 kilowatts. When
What
you're
were they
free-
running here? Same
1
thing.
kilowatt.
1 kilowatt.
30 Collins 30S1 linear,
Okay.
which had a
Yeah.
4CX1000 in it.
Okay.
And the 10 kilowatt ones down south were 208 U10s for Casey, which had a 4CX10000 in it
Then
for 10 kilowatts.
then those ones were pensioned off in the HF80s 10 kilowatt. The 8022 came in,
Yeah,
and they were
in 1983 for
yeah
them.
they were 4CX
15,000.
15,000.
Oh. The big
Some
difference.
headroom.
The big difference being that we used to change a 4CX10000A twice a year.
Yep.
Or I think it was a D actually. And the 4CX15000s would last 2 or 3 years
Right.
before we changed them. Vic Kidney, VK7VK,
Yep.
VK0VK, VK6VK I think he was.
Yeah.
And he was also Silent Key.
Mm.
We installed one in 1983 at 208, no, not at 208, an 8022, and I replaced the final on it in it when I went back in 1987, and I'm pretty sure it was the original one.
Yeah. Okay.
So they were built in Melbourne. The very first one was brought in from the States.
Okay.
But at the time there was a trade deal going with the Yanks and for Collins to get the contract, for the government contract, because they were supplied to the RAF and the Army on the point-to-point circuits between Butterworth and Perth,
Okay.
and then around Australia. So they had a series of 1 kilowatts between regional centres,
Yep.
and the main links were 10 kilowatts.
Okay.
And
And all built here.
oh yeah, so the linears and the receivers were brought in,
Yep.
but the Australian content was brought up by building the actual linears here. So transformers
There you
were
go.
built
In
here.
Melbourne, do you
Yeah.
remember the suburb?
Yeah, it was out on the way to
Springvale?
Ludale. No, it was on the Ludale
Oh
road.
yeah.
It was
yeah.
not the Churnside.
Yeah.
It was one Bayswater. No,
Yeah.
no, it wasn't.
Out that way.
On that
anyway.
way, on the main road, on the
Yeah.
road to
Mm-hmm.
Ludale.
Okay.
And then that factory, was there for some years. They also supplied other gear. Now they had an aviation repair centre that was at Tullamarine, and it's now in Sydney for aviation gear. So they were quite a big presence in Melbourne. And I've got to get my figures right. The gear was expensive. The receivers were about 40 grand, and the exciters were like a bit less, but the 10 kilowatt linears I think were $250,000 each. And yeah, so serious dollars.
The 208U10s were notorious for blowing loading coils in the output. I think they were something like 20,000 each. This is a helical piece of silver plated copper.
Yeah,
it's only a loading coil.
They're like that diameter. And they've got a
yeah.
motor this big. I'll bring one in one night, and they could tune from the bottom of the band. They tune from 1.8 up to 30 megs.
Yeah.
You go from that bottom end to the top in
Which
3 seconds.
208U10 or 802.
802.2s.
They were if it was a big jump, I think it was about 5 or 7 seconds.
Yeah.
The 208U10s were 30 seconds or more.
Yeah.
They were slow.
Yeah.
And they were pain to work on.
And the power input was about 15 kVA
Yeah.
for 10 kilowatts out. I think it's
No,
right. Correctly?
the 23 kVA
23
for 10
hours out.
kilowatts out.
There you go.
Somewhat inefficient.
Three kilowatts standby,
Yep.
of which 1 kVA or kilowatt was heaters for the final tube, which was 6 volts at 150 amps.
Yeah, okay.
Yeah. In sideband mode, it was 13 kilowatts without doing anything, just key up.
Yeah.
Key down, it was 23 kilowatts. Or CW mode.
Flippin' heck, did you actually hear the diesel generators go when you key down?
I threatened the Dezos with that I could fire up all 3 of them and with 1 Morse key them from 9 kVA load on the power to 69 kVA, and a cat was rated at 125 kVA.
Did they take up the challenge?
No. Did I do it? No, but I could have.
I could have.
Yeah. And so on that line of equipment, there were 2 channel, like upper and lower sideband.
Yep.
Then they did a 4 channel, which was upper sideband, lower sideband, lower sideband,
Yeah.
and you could modulate all 4 channels simultaneously. And that was what they were using on the long distance point-to-point circuits, because you have a couple of voice, you have a couple of data.
Obviously only 2.5 kilowatts per channel.
Yeah,
Yeah.
yeah, that's right.
We had the 4-channel exciters.
And
yeah,
2.7 kilohertz per bandwidth of each channel?
Yeah,
Roughly.
no, some if you're running data, the data channels could be narrower, but typically 2.7.
Voice channels?
Yeah,
Like normal
voice
voice
channel,
channels?
normal voice channels.
4 normal voice channels.
Or 3.08. Yeah.
Okay.
Air Force One, the 747, had a pair of those linears, a dual system on that aircraft.
Yeah.
Collins linears.
10
Yes.
kilowatt Collins linears.
Yeah.
Kicking.
No, seriously.
Absolutely. Attached to the Radphone.
And the generators that went with it?
Yeah.
Like,
Naturally.
Well, yeah. They had 4
Yeah.
engines under the wings.
Long 3-phase power lead otherwise.
yeah, okay.
Yeah, so
Flippin'
strategic.
heck.
That's what the Radphone was attached to when the president was in that plane.
Oh, well, there you go.
Yeah,
This
that's the backup.
pre-satellite days.
So what do they do? What about? Okay, they do their satellite check where they switch everything off. Do they? What happens with Air Force One when they don't have any satellite communications?
They probably have still got HF.
Probably
They have secure
okay.
HF.
There are probably so many satellites up there now that they, or alternatively, they drop into the GSM network or mobile phone network.
Well, there, yeah.
Depends where you are.
Good point.
Oh, they just use Elon's Wi-Fi up there.
Yeah. Yeah.
Well, they've got their own satellite network, so they just use their own.
It's a different world.
I think the
No,
plane
that's the
ones
military have
used-
their own satellite network. Yeah.
the main difference, I think, for the aviation one was that it ran a 400 hertz power supply and
Yeah.
we ran 50 hertz power
We'll
supply.
switch that back on again.
Magic touch on the back.
From the back.
Yep.
There you go.
Oh, there you go.
So, So just we got off course there a little bit, but
that happens when you get more than one or even one Antarctic person in a room.
Well and truly. So a fantastic find, Warren. I just that is just outrageous, and to come across it like that in like open a book.
And there it was.
So,
Yeah,
yes.
Serendipitous.
And in fact, I've just noticed that there is a rather large microphone sitting here.
Yeah.
There's somebody else recording it.
So there is probably a recording
Another
somewhere.
person.
Probably
There's
press,
also a person hiding behind the STO there who's wearing glasses.
Oh yes.
So we don't know who that is.
Out of shot. So
But
yes.
I'm sure Rex will recognise some of the dignitaries there.
Yeah.
I wonder if media have any other images of that day.
Possibly.
There'd be more than one, wouldn't there?
Guarantee they probably
Yeah.
do.
I'd be surprised. I think Tom Maggs and Hood were the two radio operators at the division at the time. If they weren't there somewhere, but I don't recognise them in that.
There's probably 15 other people off to the
Brian
side, you know.
Taylor.
Yeah.
Because it's not every day you see.
Charlie.
Well and true.
So I wonder what else he was doing. He wouldn't have just come out for that. He must have been doing other stuff around Australia that year.
Oh, well, did you end up getting the book? Did you end up?
No, I feel like I should know. But he had. I guess that's not mentioned on the bottom of that picture, is it, by any chance?
Hang on. Whoops.
He had a very busy schedule. We can't read the fine print there, can we? Charles.
Prince Charles.
AOD in Hobart.
No, hang on. It's better if I
It's during his visit to AAD in Hobart.
tries some of the equipment during his visit to the Australian Antarctic Division in Hobart, Australian Information Service.
Yeah.
Yes.
Okay. Well, what I do recall, having read on the next page, was that he visited several places on that very day. So in fact, he came down to Hobart, and I think he was whisked off straight to Kingston for this event, and then right after that he was back in Hobart for something else.
Yeah.
So
Have to keep your eye on the plaques around the place of various things and see whether he opened something else.
I think one thing comes to mind. He was offered sledging biscuits, and so the label said the sledging biscuits that Prince Charles refused or something like that.
Sledging biscuits.
Oh, they were marvellous.
Oh, sledging, as in sledging on the ice.
Yeah.
Yeah.
Yeah, like
The
high protein,
okay.
high
the
protein
original
biscuits.
proper sledgies were really good, and then they got replaced with army issue things that were also called sledgies, and they were rubbish.
Yeah.
The original ones were about 100% fibre, 100% protein, 100% something else. Oh, did I
Think you don't want to know about it.
did I mention the fibre?
Right, okay.
Probably fat.
Oh yeah,
Okay.
big fat in there. You
Dear,
could live
dear.
off the damn things.
Okay. That
They
was
used-
ration
I-
pack in a biscuit. Yeah.
I used to like them with butter, Vegemite, and then I'd sprinkle more fibre on the top.
Okay.
So how old were they? Were they sort of First
I
or
don't-
Second World War?
I don't think they aged. No, they got them made in a special batch at Swallows or
Oh, Swallow
whoever
Biscuits in
made-
Melbourne.
In Melbourne,
Yeah.
they used to make a special batch every few years for them
Every few years, that'd be
and
right.
send down bulk amounts.
With extra fibre.
Oh, they were good.
AAD, they want extra fibre
honestly.
down there.
Honestly, think about it for a while. If you're out in the field, fibre is really a godsend.
Yes, okay.
You don't want to be caught
Yes.
with your pants down for too long. It's cold. Did I mention the ice?
Cold on the extremities, yes.
Did I mention standing aside a tide crack with seals and penguins?
Oh, Helen.
Okay.
The visuals worse than the information. As long as it wasn't a leopard seal.
he spent too many winters down south.
Yeah, well, truly. Oh dear, oh dear.
No, I really did like the sledging. Lots of people didn't. I quite liked them.
Okay.
Everybody's got their own.
We'll see.
So do you prefer Powell or Chum now?
Neither. We won't. If you want to talk about pen blocks,
Actually,
that's what we fed the dogs, and you didn't want to eat one of those. They were horrible.
Right. Okay. Well, on that note, we might.
Kick us out.
So we're looking
Thank you very much.
Thank you.
Thank you.
I'll give a lecture on toilets in Antarctica.
Yeah.
Really fascinating.
It's a bit yeah.
With photos.
Yeah.
Very good.
Thank you, Warren, for finding the photo.
Very good.
Good stuff. All right. So, just wanted to finish off. We the 3.4 gig experiments that we have been doing with our new grid pack. So our 27 dBi grid pack antennas. I've got a photo of our tests. One of our tests that were done on the weekend. This is okay. That looks awfully dark. Now, this is our. Ooh, let me go out a bit. Beautiful. Okay. So these are the 27 dBi grid packs. They are very nice. They come out of China. The grid packs are powder coated, so they're a bit better than the original Ostar grid packs that were just they were die cast metal without any coating on them. There is the feed. I'm not sure whether you can see the feed in there. Can we? Oh, there we go. Now you can see the feed. The feed here comes to a obviously a reflective element to grab all of the signal that's coming in via the grid pack. There was a few tests that I did. I could put my hand around the inside of that particular feed and reduce the amount of signal that was actually getting there quite dramatically. So I would love to take the screws out of that and see what's actually behind that little radome. I was using the 705 and you can't really see it, but on the back of the grid pack is the SG Labs transverter with a little N-type elbow. 705 on the chair there, and the battery on the ground, and there's the tripod, the lighting tripod, thanks to the Resource Tip Shop. Now we now all have these particular antennas, and so our test on Sunday was Richard out at no, sorry, it wasn't Richard. It was Steve VK7OO. I'll get it right, Steve, if you're watching. Steve with his. It was Alan with the smaller of the grid packs, the Ostar grid packs, the one lent from myself, and I was on the big grid pack as well. So it was Steve and I on the big grid pack. All pointed at Mount Wellington, and honestly, it was 5 and 9 plus signals. So definitely a great test, and an even better. Now, who's this from? This is probably from Steve. Oh, there we go. And here's Steve's setup in his roof. So thank you, Steve. You are watching. So this is Steve's in his. This is the end of the gable in his house, and this is. And go ahead, Steve. I'm listening now. I'll just turn you up.
Yeah, Roger there, Justin. That's the grid pack aimed at the rear gable of my shed at Mount Wellington, and it's just a little bit up and a little bit left of the plane of the shed.
Oh, there you go.
Well, fantastic. So thank you, Steve. Now, Steve is Steve, I think, still in quarantine. Are you, Steve? Until I think it was Thursday night. You said over.
13 or 14.
Right. Okay. Okay. So I dropped off. I dropped. Oh, that's there's a real shine on that. Anyway, maybe I'll come in a little bit. That should reduce that flare. And you can see. So that's the back gable of Steve's shed. So I dropped the bigger grid pack off for him, and mounted in a good quarantine activity of mounting the 3.4 in the shed. So now is that fixed, Steve, or is that on a some sort of rotator over?
That's on a pan tilt mount, but it's all bolted off, fixed in that position. There's barely enough room to aim it in, so it's quite a confined space.
Oh, okay, cool. So yeah, it is fixed, but you've got the ability to do a pan or tilt on it and then lock it off. So fantastic. Oh well, you were a fantastic signal. So having that extra gain really does assist. So and when Alan puts his together, we'll have Alan's. So we'll have 5 on 9 centimeters. We've got a couple up north who have the same setup with the SG Labs transverter, and they also have the larger grid packs now. So I'm hoping we can get some north-south 3.4 gig activity happening, which is fantastic. So anyway, that's a bit of an update on our 9 centimeter experimentation. So thank you, Steve, for coming in there, and thank you for watching. Great, absolutely great stuff, and a definite improvement. Can I just say, definite improvement from the PCB antenna, which I have to say was doing exceptionally well. That's the previous arrangement with Steve out on the back deck area. With the PCB antenna straight out of the SG Labs transverter, so a definite improvement from the previous arrangement. So good stuff. Thank you, Steve. Now I have some dates for people that we only came up with last night at the Reast committee meeting. The very first one is, and we, following up on our Antarctic adventures earlier, we have almost 99% confirmed our presentation night for the 1st of December, which is Wednesday the 1st of December at 7:30. Hayden has been able to rope in Paul VK7OO, who has just come back from Antarctica. So he's hopefully giving us a talk on his travels down south. So that will be fantastic. That's the 1st of December, 7:30 p.m. Our Christmas activity, which is a barbecue for both the WAGs and the DATV night, on the 15th of December. So that should be a great night. And our open day, we have looked, and it looks as if it will be on the 16th of January 2022. So that's where we've moved our open day to. We'll get some communications out around all of that. And also our AGM we've set for the 6th of February 2022. So there's some dates that will get up on the website and get out in the email newsletter and all of that sort of stuff. So yeah, that's the lowdown. We've got a whole lot of videos on measuring crystals, and also there's a wonderful one that Chris VK7KAJ sent me, which he titled New Retirement Options, and I'll leave it at that. And then there is some funnies in there as well. But how to design a crystal filter, testing crystal filters with NanoVNAs, that's from Peter Parker. and also measuring crystals with the Nano VNA, which features the rig, the little jig that I'm going to be making up. So so yeah, I will show you that next week. Anyway, an hour 20. So we've gone way over our normal time. So apologies for that. Anyway, I hope people have got something out of tonight. Crystals and Antarctica and Prince Charles and all sorts of things. So it doesn't get much more diverse than that. Anyway, we'll bid you 73. Have a great week, and we'll catch you next DATV night 73, and we'll catch you next time. Cheers.